Welcome to this video tutorial about surface generation with Match 3ds. We want to introduce here the different production workflows that are possible with Match 3ds and also to show which setup you need to get good results. For typical products, normally we have the orthophoto generation, the True-Ortho photos, and the textured meshes. The orthophoto production is a very classic standard production line where typically you have a digital terrain model. Then we have aerial images that will be singly georeferenced. So if I have 100 aerial images, then I will get 100 orthophotos. Then these orthophotos have been generated with a correct terrain model, and then we stitch them together. So in this case, through seam lines, the orthophotos will be merged together to a seamless mosaic, which is then a typical orthophoto workflow. With Match 3ds, we can also extract these type of data, where we would need, in this case here, the feature-based matching, and which is a very fast algorithm. And we also only need for this process typically an 80-30 overlap, and it's then used together with our orthobox, where you can use AutoMaster for the auto rectification and AutoVista for the seam line generation, the radiometric correction, and the mosaicing. The True-Ortho photo generation is also provided with Match 3ds, and for the True-Ortho photo generation we are offering the matching algorithm SGM 2.5D. You will need to get good results, an 80% overlap, and it is much more time consuming, but the advantage of course is superior. So instead of having buildings that lean into our images, because as I mentioned before, typically with the classic orthophoto you are using a digital terrain model, so our terrain will then be on the ground, and if my projection center is not perfectly just over the building, but a little bit to the left, right, upper or downside, then the building is leaning into our orthophoto, and therefore we are losing content. So we are not able to see here into the streets. We are also not able to see here on the street, and therefore we cannot extract information from the pathway or here from this vegetation behind the building. So these things will then get lost in a classic orthophoto. With True-Ortho photo, this is a full automatic process. You can achieve this result with Match 3ds running the SGM 2.5D process. And finally, also we offer in Match 3ds also a textured mesh. The textured mesh is typically at the moment more for visualization. It offers for non-photogrammetric or even non-surveyors a very detailed and clear view to a scene. It also includes, in this case, the real texture of objects, which makes the interpretation very easy. And also it allows to do, in this case, also some inspection for regions and areas or for project plannings. All of these three products, the orthophoto, the True-Ortho photo, and the textured mesh, all are available in Match 3ds for processing. For the 2.5D, it is an 80% overlap flight necessary to get viewing angles on each location, so that we can extract a very good dense point cloud. So one of the other possibilities would also be a multi-head system. So instead just flying a nadir camera, you use a camera head system that has multiple cameras, which are not only looking straight down, but also with some degree typically 40 degrees, but also other systems are existing on our scene. All the photos are taken in a synchronized moment, so each single photo from this multi-head system, or each single camera from this multi-head system, has exact GNSS information and IMU information, and we can also have for each camera its own, or we must have for each camera its own camera calibration. In our demo data that we will use today for our processing, we use a dataset from Aerovest, so we want to give thanks to them, and it is flown with an EG Urban Mapper, which is a very large scale long footprint for the nadir part, which has 28,200 pixels times 11,500 for the nadir. And the data also includes oblique data, which we will not use today. We will only use the nadir images for our process, and they have an 80-70% overlap. So 80% in-flight direction and 70% cross-strip overlap in this case. The data structure from the demo data is looking this way. We have our images folder, and in the images folder we have for each camera, for the nadir camera, for the cameras looking to the north, to the east, to the south and to the west, each are in separate subfolders. To process our data we will use a smaller area in the center, mainly because of enough overlap, so we can have then enough different model selections, and therefore we can process a nice, good looking True-Ortho photo. Then we also have a project for just the nadir dataset, which we will use today, and also we will provide a dataset or project for the oblique part, which is still currently in work. In the next videos we will then go through Match3dx. You can start Match3dx from the Applications Master. You will find it in Capture Match3dx, and then after you select Match3dx, the Match3dx commander opens up. And then depending from the different workflows, we will then go through the different parameter sets. We will show what type we have to select to run the feature-based matching or the cost-based matching or the semi-global matching processes. Also about the strategy, how we can define parameters for each of these processing types. Then also how we can run on sub-blocks just to run on specific images. And also about the output we will then talk. And then in the strategy itself we will then explain here the settings. So each of the processing types like feature-based matching or semi-global matching has its own parameters to be set, and we will explain them in detail in the videos coming up to this one here. So thank you very much for watching this video tutorial, and hopefully seeing you in the next following ones. Thank you, goodbye.